So this is called the vector equilibrium, or the cubocatahedron, and the distance from the center point to any of the vertices, but you have to think of it in 3D. This vertice to the center, this vertice to the center, they're all equidistant. So there's going to be 12 vertices in 3D. It's the only convex polyhedron where that's true. So practically speaking, if you connect all the 12 outer points with equal length struts, the outer points are connected to each other with struts of the same length. So it's kind of a tension or compression balance, and no strut or none of the lines are under any more load than any other by geometry alone. So that's where they get the equilibrium from. So it's got structural symmetry. I know some people use it with energy and consciousness. It's probably a good metaphor. So we could use it with the close packing of spheres. So if you take, one sphere, you're going to pack 6 around them, and then another 6 on top of that. And so 12 identical spheres will all be able to touch the center. So this is one way that atoms pack in crystal lattices, copper, gold. And so it's an interesting geometric shape. But first we want to make sure that our compass and the point and pencil are lined up. So always make sure that they're pretty even. And we want to make a length that will allow 2 of the compass length so that it doesn't go off of your paper. So let's draw the circle. And we're going to go directly on top and put the point of our compass here. As most of you know, 6 circles will fit perfectly around a circle. So where the 2 meet here, we'll put our compass, we'll draw another circle. We'll do that all the way around. And we have our seed of life. And like a seed, you plant it and many things grow. These are the seeds of geometry. So here we have what we call the seed of life. And what we're going to do first is we are going to make a hexagon around the center. So take my pencil. From here to here, I'm going to connect. I like to put my ruler down, put my pencil down first and then line up my ruler. You're more likely not to be fooled and miss the spot. And now in normal construction work, when we're doing art or design, we take our time, so don't rush. Sometimes we're a little bit quick when we're demonstrating. Just like math, take your time and do it right. So now we have our hexagon going around. The next step is we're going to draw like a star shape or a hexagram. And so we're going to go from here to here, sort of make the point of the stars. So we see here and here And now the next thing we're going to do is we're going to go from one of the points of the star to the other side across from it, and we will draw the diagonal. We'll do that to each of the 3. And then we're going to draw a triangle. So the first triangle we're going to draw is here, skip one, here, skip one, and here. So we're going to draw from here to here, here, skip one, here, and then we're going to do the same thing with the other vertices. So we're going to start here, skip one, go to here. And then lastly, we're going to make the diagonals of those triangles and do the same thing we did a moment ago. So I'm going to go here, the other side across from it to here. So if we look at these little seeds, I'm going to go through them diagonally. 1, 2, 3. And so if I use another color, you can kind of see a little bit of the design. I'll use green. I'll outline my hexagon. Then we'll outline the triangle in the center. And then we'll go straight down, make a rectangle. We'll do the same thing this side, and then on this side. And so if we wanted to make it a little bit darker, we could. Maybe I'll use another color. Maybe I'll do some blue here, and I'll do the upside down triangle in blue. Inverted. And then maybe I'll do the rectangles connected to it in blue. But my blue is running out. Hopefully we can make it work. And then, I don't know, I guess we could use orange for the diagonal lines that we did. So we'll go from here to here, here to here, here, and then we'll do the diagonals for the triangle, for the little seeds. We'll go here, there it is.